Hello students, welcome back to Tuition Masters, and today we are here with doing a very important chapter of physics, that is motion. So this is a lecture 1. So let's understand about motion, and within approximately 2 more lectures we will complete this topic. So what do we understand by motion? Motion is nothing but the change in position of the object with respect to the time. That is the main thing. When an object is moving, okay, when the object is moving with respect to the time, we will say that the object is in motion, right? So whenever the any object, like take suppose a car, my car is moving with respect to some time on the road, so that is the motion, correct? So whenever there is a change in position of a body with respect to time, take suppose this is my ball which started from point A and it ended till point B. Okay, so within 9 seconds it reached point B. So with respect to what? With respect to the time of 9 seconds, the ball could reach to the position B. Now there are different types of motions we have to study. So the first type of motion is rectilinear motion. So this is known as the motion in a straight line. Whenever the motion is happening in one straight line, for example, the ball went from point A to point B in a straight line. So that is known as the rectilinear motion. Next is the circular motion. Now, when I say circular motion, what do we understand by circular? Motion of a body along the circumference of a circle is known as the circular motion. For example, the earth revolving around the moon. What is that example? It's revolving around its orbit, correct? It's revolving around the orbit. So when it revolves around its orbit or in particular place, that is known as the circular motion. Next motion similar to circular is rotational motion. When I say rotational motion, there is an axis on which the motion is occurring. On an axis, the body is revolving. For example, your fans. When I say fan, this is the axle over here. Okay, on that axle, the object is rotating. That whole line is the axis of rotation. So rotational motion means when there is an axis and with respect to that axis your object is moving. That is rotational motion. Next is periodic motion. Motion that repeats in equal intervals of time. So, what can be an example which repeats equally? That is, take suppose the revolution of the different seasons. Those are the example of periodic motion, where in equal intervals of time the things are occurring. If you say an example of your exams, so periodic exam means that after particular completion of syllabus, that periodic exams take place, right? So that is periodic motion. Next, as we understood, car moving on the straight road, what it is? It is rectilinear. Correct? It's rectilinear motion. After that, wheels of a car are moving based on what? It is rectilinear motion. Correct? When the car is moving on the straight road, that's rectilinear. Now, what about the wheels? What about the wheels? Do they have any axis? No, they don't have any axis. So they are moving in a straight line. But what about the wheels? They are moving in a circular motion. Correct? Circular motion, or we can say rotational motion or rectilinear. Which one? It will be nothing but as the car is moving in a rectilinear motion, right? But what about the wheels? The wheels are rotating. Correct? So that will be rotational motion and rectilinear motion. Next is a simple pendulum, that's a to and fro motion, that is known as oscillatory motion. It is a to and fro motion. So you can say it as oscillatory as well as periodic motion. So let's move towards our next topic. So when I say about distance, so what do you understand by distance? I can say that the total length covered in any journey or any motion is nothing but the distance. Correct? So let's understand distance and displacement with an example. Let's say that I have two towns, town A and town B. Okay. Now there is a direct way, a straight road from town A to town B, there is a straight route. Okay, there is a straight road. But unfortunately, due to construction work, that straight road is blocked. I can't go through that straight road. Now, what I have to do? I have to take a detour. I have to go from town A to town B through another round way. I have to go. Correct? I can't go straight now. I have to go on the other way side. Correct? Now, we have that from town A to town B, that straight path was of 20,000 meters, and the detour the from the round one is of 50,000 meters. So distance is always measured in meters. What is the distance from town A to town B? 20,000 meters when I go to the straight path. Now, what can we explain from this? Is it a scalar quantity or is it vector? Right? Now, if I talk about kilometer, 1 kilometer is equals to 1,000 meters. Correct? It equals to 1,000 meters. So this means that the straight path is 20 kilometer and detour is 50 kilometer. Right? Now, what about this question? Is it scalar? Is it vector? So let's understand that later, but let's understand about displacement first. So when I say displacement, it is a simple clear word, that is distance with direction. Now I want the distance, but in which direction that distance is going? If I combine them, I get the another term, which is displacement. What do I get? I get displacement when I have the distance and the direction. So when I say displacement, again let's say the same example. What was happening? The straight road was of 20 kilometer. The detour road, the round way road, was of 50 kilometers. So obviously the detour is more distance is there. Correct? Now take suppose it was 20 kilometer north from home. Town B is 20 kilometer north from home. So 20 kilometers is the distance here. North is the direction. So when direction is specified, direction as well as magnitude is there. So it is displacement, and so displacement becomes which quantity? Vector quantity. Okay, let's see one more examples and then determine what is distance and displacement, whether they're scalar or vector. So distance we have to find out, displacement we got it, it requires the magnitude as well as the direction, so it is vector. Now say that there is one mom, she has said her child to not move from her place till the time she's going and sleeping. Okay, so the mom says that don't move, I'll go and come. So the mom went to sleeping. What did the boy do? He was roaming here and there. Okay, he moved in a path, but when the mom came, he stood back in his original position. Now there was lot of distance covered but zero displacement. He moved all the way around here, where everywhere, but he came back to his original position. So what can we say? That distance, too much of distance was covered, but displacement was zero. Correct? So when I say that distance is 20 kilometer, and if I want the displacement, I will even have the direction, which is 20 kilometer east or west. Now distance, always remember that distance is always greater than the displacement. Distance, the measurement of distance will always be more than the displacement covered. So passenger charged based on distance or displacement. Whenever you go in a taxi, bus or anywhere, what do they use? Do they use the distance or do they use the displacement? Obviously they take the distance, because we know that distance is more, it will cover more. So when distance is more, so they will also get more money, so they are charged on the base of distance only. So what do we conclude from this? When I say distance, so distance is a scalar quantity, it doesn't require any direction, but displacement is a vector quantity. Alright, so here when we talk about the same town here, so what can I say? Which one is the distance and displacement? The displacement is the straight one, 20 kilometer, and the distance covered is 50 kilometer. Alright, so this is what we have understood till now. So here also remember that displacement will always be the straight path we are taking, the shortcut method. Okay, displacement is a shortcut method and distance is the long routes we are taking. Now again, let's say an example here. A boy wants to go from he is in a cycle, he wants to go to a mango tree. Okay, this is a mango tree. He wants to reach the mango tree. Okay, so there are two possibilities. First, he can go from his current position to his home, and from his home he can go back to the mango tree, or else he can directly go to from his original position to the tree. So what happening here, when we go from point A to point B, it covers 4 meter, and when it goes from point B to C, means from house to tree, it is 3 meter. In total 7 meters are covered when it goes via home. But when he goes directly from his position, current position, to the tree, it is just 5 meter. So which one is easier, via home or direct? Obviously directly is more easy. So now when I say negative and positive kilometer, so how do I determine it? Displacement, it can be zero and it can be positive also, it can be negative also. Displacement, always remember, it can be negative, positive, zero, anything. But when I say about the distance, it cannot be negative or zero, it will always remain positive only. Alright, so for example, person is cycling 3 kilometer, 2 kilometer, minus 1 kilometer, it can happen just in case of displacement, not the distance. So here if you see, there is a person moving here and there. So distance is how much? For this person A has to go to this person B. Not B, okay, I'll take that C. The person C. So what is doing? If he goes and meet person B also, then from B he goes to C. So it will take 4 plus 3, 7. But if it directly goes to C without meeting B, so it just takes 5 meter. So the displacement is 5 meter, whereas the distance is 7 meters. So I hope distance displacement concept is totally clear. Alright, so here if you see, displacement at point A is 0. He didn't move, it is 0. And distance traveled is also 0. Right? Distance, okay, distance can be 0, but it cannot be negative. So distance is 0 because it didn't cover anything yet. Correct? Now, next important thing is about uniform and non-uniform motion. What do we mean by uniform, non-uniform? What are these things? So let's understand them. So when I say uniform motion, it has a particular definition. Correct? Let us see. So a body is said to be in uniform motion if it travels in equal distances in equal intervals of time, no matter how small these time intervals may be. So, very clear cut explanation it is that when I say uniform motion, uniform, it is constant. It is constant at an equal intervals of time, it is covering equal distances. That is uniform motion. For example, every 5 minutes the car is taking a rest, so that is a uniform motion. For example, movements of hands of a watch, they move at a particular time. Correct? Rotation, revolution of earth, it is not like any time, no, it happens at a proper intervals. Movement of blades of a ceiling in a fan, that also happens in equal intervals. Correct? That is uniform motion. What is the dt graph? What do we mean by dt graph? Dt graph is the distance time graph. So for uniform motion, the dt graph is always a straight line. There will always be a straight line. For example, 50 meter, I guess, in 1 minute, then 100 meters in 2 minutes, 150 meters in 3 minutes, then 20 meters, 200 meters in 4 minutes. Like that, this is a dt graph always. For any uniform motion, this will always remain the distance time graph. Now say that there is a particle It has a speed of 3 kilometer per second. It covers 3 kilometer per second. Okay, now if I want to find how much is the everything speed etc, so how will I do it? Take suppose the what is the constant distance covered? It is when it is considered just 3 kilometer per hour. Okay, and what is the total time? Total time is 1 second. So 3 meter per second into 60 seconds, that gives me how much? 180 meters, correct? And distance over unit time, what is the distance over here? It is 3 meter over the unit time is 60. So what will be the units of speed? So speed can be measured in various units, for example meter per second, centimeters per second, miles per hour, kilometer per hour, we can measure it. So we will continue about this more after doing non-uniform motion. So I hope uniform motion is clear. Now, what about non-uniform motion? When I say non-uniform motion, the speed is not constant. It's not like in equal interval that's covering equal distance. No, that is not the case. So an object is not covering equal distances in equal intervals of time. That is non-uniform motion. So when I say the rate of motion, that is known as the average speed. So take suppose that there is object A, object B. Okay, so object A, it covered 60 meters in 60 seconds. It covered 60 meters in 60 seconds. So what will be the total distance covered? It will be, average speed is nothing but, we can write it over here also, average speed is equals to total distance, which is traveled divided by the taken time, divided by the taken time. So what did we get here? The total distance was 60 meter. Elapsed time or the taken time was 60 seconds or 1 minute. So what do we get? 1 meter per second is the average speed. Now, it covered 60 meters in 1 minute. As I said, this 60 seconds I can write in 1 minute also. So I can write it as 60 by 1, that is equals to 60 meter per second. Correct? No, that is not correct. It is not at all correct. Why? Because I am using the unit of meter per second, right? So I can't use minute over here. I can use only seconds. I have to convert that 1 minute into seconds. So what I can write? I can write 60 meter, 120 meters in 1 minute means 120 divided by 60 I will do, not 1. So that will give me 2 meter per second. So what is the definition of non-uniform motion? A body is said to be in non-uniform motion if it travels unequal distances in equal intervals of time. Very important thing, it is covering unequal distances but in equal intervals of time. I am having given every 5 minutes I've set the car to take break, but it's taking in 5, then 20, then again 5. That is, it's covering unequal distances in equal intervals. For example, oscillation of pendulum, motion of a train, person jogging. Now person jogging, is it like every time you will do at a constant speed? No, right? It can go here and there also. So that is non-uniform. What is the dt graph of it? Again I'm explaining the dt graph of the non-uniform motion. So here it is not constant, so it will always remain curved. What will it be? It will always remain curved only, the distance time graph of a non-uniform motion. Now let's understand the differences of uniform and non-uniform motion. Definition already I've explained. Let's move ahead. How much distance is covered? In uniform motion, equal distance is covered in equal intervals. Correct? In 5, in take suppose in 10 seconds, 5 meters. That is equal. But in non-uniform, it doesn't covers equal distances in equal intervals. It doesn't do that. Now, average speed, that is a one important point. What is the average speed in uniform motion? It is just the same as actual speed only. Why? Because we are just doing the, it's constant, the speed is constant, so no need of average speed. But in non-uniform, the speed is changing. So that's why we have to take a average speed. So I'll write it in this slide of average speed. It is only applicable in non-uniform motion. Only in non-uniform motion one can use the average speed. Okay, in uniform motion the average speed is nothing but the same speed which is currently there. Rectilinear motion, what is the acceleration? In uniform motion it is acceleration is zero because it's covering equal speed, equal distance, equal intervals. But in non-uniform motion it is non-zero, it can change. DT graph, as I said, uniform motion is always in a straight line like this. If this is my graph, it will be like this, distance time, correct? But when I talk about non-uniform motion, it will always be curved. It will be always curved. So these are the differences. Again, important thing, it can come for your 5 marker questions. Okay. Now, what about speed? Now you might have studied in your earlier standard speed is equals to distance by time. Correct? If I say speed is 50 meters per second, time is 1 minute, what will be the distance? Distance is speed into time. So 50 into 60 is 300 meters, 3000 meters. So 3000 becomes my distance. Correct? Now remember that speed again is scalar because it just requires the magnitude, direction is not required in speed, so it is a scalar quantity. Now distance, let's say again town A, town B, we have it again. So the distance is 50 kilometer and we know the displacement is 20 kilometer north, right? So when I add the speed plus direction, when I do speed plus direction, what is my answer? I get the velocity. What do I get? I get the velocity. When distance and direction are added, we get displacement. When speed and direction are added, we get the velocity. How do we calculate now? Let's understand that. Velocity, the unit again is meter per second, that is the SI unit. Speed again is scalar quantity, but velocity is vector. Why vector? Because speed and direction both are required. So that's why it is vector quantity. Magnitude, direction both is required. So it is vector. Now, how do we calculate it? See this. Velocity units we got it. Now, as I had said, from town A, town B, the displacement is 20, distance is 50 kilometer. Now, average speed was what? Total distance by total time we can do. Total distance was 50. Time was 2 hours given to us. So, I can say 50 by 2, that is 25 kilometer per hour is the average speed. Now what is average velocity? Average velocity means that I am going to use my displacement. In speed distance is used, but in displacement I will but in this thing, the velocity, I am going to use the displacement. All right, so let's see. As I said, displacement at 20 by 2 gives me 10 kilometer per hour. Now, here as I explained you distance, let's say another condition, let's say distance is 300 kilometers and per kilometers, okay, 300 kilometers, time is 1 hour 40 minutes. What is the average velocity? Now, average velocity is displacement by time. Now how do I find the displacement? Displacement is 0. So 0 divided by the time, 0 only. So average velocity is 0. What about the speed? Now 30 kilometer divided by 100 minutes. 1 hour is 60 minutes. So 60 plus 40 is 100 minutes. So what can I do is 300 into 1000 meters if I do. Okay, 300 into 1000 meters is 300 kilometer and divided by 100 into 60 seconds, that is 100 minutes. So I will get 50 meter per second. Okay, so that is the speed. Now when I say about velocity and acceleration, when velocity changes, acceleration will also differ. So, but now let's say here there is a constant speed by a car of 80 km per hour and of a aeroplane 1000 km per hour. which case do you think that acceleration is in? Or you can pause the video and think about it. Okay, so when I say about acceleration, there will be no acceleration both of this. Why? Because acceleration and high speed, acceleration will not be equal to the speed. Acceleration will be that time when there is the change in velocity. This is the speed given to us. I don't care about the speed. Acceleration I will get only when there is the change in velocity. So velocity, as I said, it is speed plus the direction. So what about the acceleration? So yes, change in direction is change in velocity, right? So when I say acceleration, it is defined as the rate of change in velocity. When the velocity changes, acceleration is there. And acceleration is equals to change in velocity divided by time. So acceleration, if I want to find out, velocity divided by time gives me the acceleration. Now how do I find velocity? Velocity already given, but if you have initial and final velocity, initial is written as u, final written as v, and time is t. So acceleration is also written as the final velocity minus the initial velocity divided by time. That gives me the acceleration. Now here if you see A to B again, so the time taken is 5 seconds, initial velocity is 0 and final velocity is 10 meter per second. So 0 minus 10, okay, and what will I get? 10 minus 0 divided by 5. So 10 minus 0 is 10 only, so 10 by 5 gives me 2 meter per second square. So remember that the unit of acceleration is meter per second square. Alright, so let's see ahead now. So we know that it is the acceleration and velocity, they both are in the same direction. So direction is involved, so it is a vector quantity. And the last topic for our today's session is about graphs. Okay, now graphs in mathematics, let's understand from mathematical visualization. We know that each of these boxes are 1 centimeter squares, correct? Let's say that there are a few 6 people: Zen, Asha, Ben, Carly, Dave, and Elon. They spend this much of money. Okay. Now, what do I say about the range? Range is the highest minus the lowest. So, highest is by Carly and lowest is by Zen. So, 300 minus 100 is 200. So, the range is 200 over here. Correct? And 1 centimeter, I have the key of this is 1 centimeter is 50 rupees. So 50 into 4 gives me 200. So how do I construct the bar? I'll draw my xy axis. Then I'll write the kids A, B, C, D, E and Z. Asha, Ben, Carly, Dev, Elon and Zen. And I'll write them marking 50, 100, 150, 200, 250, 300. Why I'm doing this? Because 1 centimeter is 50 rupees. So I can writing that key. So here if we talk about in physics, we use the distance time graph, velocity time graph, everything we use, right? So say suppose I have time 1 second 2 meter, 2 seconds 4 meter, 3 seconds 6 meter. This much distances are being traveled. So how do I construct the bar? Like this. Remember this part is very important. So how I do is I will write here 1, then it is 2 meters, 4, then 2 seconds 4 meters, then 6, 3. So which kind of motion is there? I want this to be written in the comment section below. What is this motion? What is this type of motion? Let me know in the comment section below which motion is this. Is it uniform or non-uniform motion? So thank you students for watching today's video. I hope we have done quite many things, and in the next session we'll continue also. So don't forget to like, share, subscribe and comment down the homework answer also. And if you have any other queries, you can reach me out and I'll be seeing you in the next lecture. Till then, take care and goodbye.